Hi everyone, I'm Zhu Zhao from Amazon Web Services. I'm very glad to introduce our work for object-centric multiple object tracking. This work starts from unsupervised object-centric learning. The object-centric models bind objects into a couple of slot embeddings and can be trained with a self-supervised reconstruction loss. Most impressively, the OC representations are rich and versatile, containing enough object information such as position and appearance that are very important for downstream tasks like tracking. However, as highlighted by the red boxes, an object may appear in different slots across time, showing bad temporal consistency. Besides, the pothole issue are not fully explored, which allows slots to only track parts of an object, shown by the dashed arrows. In this work, we take the steps to bridge the gap between object-centric learning and multiple object tracking without additional supervisions. We propose an OCMOT framework, and it extends the traditional object-centric model with a self-supervised memory. Our design focuses on two key issues: track objects as a whole and track objects consistently over time. For this, we store historic information in the memory to fight against noise and occlusion. This helps improve temporal consistency via a memory rollout module. Besides, we consolidate slots into memory buffers with an index merge module, which helps to solve the pothole problem. For training the association function, which is the index matrix I, we encourage the object features stored in the buffer to be similar to the slot that will be assigned to this buffer. And the optimization process follows the expectation maximization paradigm. We visualize the MOD results of the object-centric baseline SAVI and our method. Cater is a synthetic video dataset in OC community, while Fishbowl is a MOT dataset containing more complex scenes and occlusions. So we can see that SAVI fails to track objects and there are many ID switches. In contrast, OCMOT produces consistent tracking results even when objects frequently interact with each other. To better understand how we can handle occlusions, we visualize the memory rollouts here, which are used for association. We decode them into object reconstructions for visualization. The memory starts to roll out after the first frame. We observe that the memory can predict a complete object even when it has been partially occluded. So that's why we say it is a model representation. For evaluation, we compare our method with other baselines, include one OC model, 3 unsupervised trackers, and 1 supervised tracker MOTA. We can see from the table, OCMOT substantially outperformed the video OC model and other unsupervised trackers. It is also competitive with MOTA trained on expensive object-level annotations. For evaluation on Fishbowl dataset, we found that only adding partial detection labels can greatly improve the detection performance of the OC model that is necessary for the tracking purpose. In this paper, we still argue that the major limitation of OCMOT is the detection performance of the OC models on real-world videos. They cannot predict accurate object masks even when trained with mask annotations. The below figure shows the segmentation results of the dinosaur model, which is the most suitable OC model for the real-world grouping task. So to extend our work to real-world video, one possible solution is to replace the OC model with a strong real-world segmentation model like scene model to accurately segment objects from the COCO categories. So after that, we train OCMOT with the self-supervised loss on track any object dataset. Impressively, our method also shows good tracking performance for real-world object association, even for the hard cases. Yeah, for conclusion, we would like to highlight that, first of all, OCMOT is the first video OC model that can be applied to the MOT task. Next, with an object association in a self-supervised manner, which is agnostic to the detection module. Last, OCMOT can handle the occlusion during tracking and the pothole issue that is specific to OC models. For more details, you can check our GitHub repo by scanning the QR code below. Thanks for your interest.